So today we will be working on geometric sequence examples. Here is the equation for geometric sequences. A sub n refers to any term in the sequence. A sub 1 is the first term, r is the common ratio, and n is the location of the specific term. The common ratio cannot be 0. And to find the common ratio, you would divide any number in the term you would divide any term in the sequence by the previous term. So in the first few problems we are doing today, we will be finding the equation for the geometric sequence and then finding the 8th term of that sequence. So in the first problem today, we have 64, 32, 16, and 8. So the common ratio of this is obviously 1/2, since 32 divided by 64 is 1/2, 16 divided by 32 is 1/2, and 8 divided by 16 is 1/2. And also the first term of the sequence is 64. And this can actually be simplified, since we know that 2 to the 6th is 64. And we know that 1/2 to the negative 1 is actually 2, so 1/2 to the negative 6th is 64. Now, by combining those exponents, we get 1/2 to the n to the n minus 7, and then that's our equation. And then we plug in 8, so 8 minus 7 is just 1, so we get 1/2, and that's the answer. In this, it's a little more complicated since we have fractions. So in order to get rid of, to simplify it, we are going to multiply by the reciprocal of the denominator. So the 5's cancel, and you're left with 2 as the common ratio. And the first term is 5/6. So that's as simple as the equation gets. So now we're going to plug in 8. So 8 minus 1 is 7. And so the answer can be simplified to 320 thirds, which is actually 106.667. And that's it. In this problem, we have decimals. So the common ratio is 0.04 divided by 0.4, which is just 0.1. And we can clarify that by also doing it by the third divided by the second term, which is 0.004 divided by 0.04, which is also 0.1. So that is correct. So 0.4 is the first term, and that's our equation. It can be simplified by acknowledging that these can be turned into fractions. And then by taking out the 4, we get 4 times 1/10 times 1/10 to the n minus 1. And the 1/10 can be combined too, because that would be 1 plus n minus 1, which just simplifies to n. And then we plug in 8, and we get 4 divided by 10 to the 8th, which is just 4 times 10 to the negative 8th. This problem is a little different. We're not going to be using the geometric sequence formula, and instead we're going to be using just the common ratio formula. So we know that x minus 1 is the first term, x is the second term, and x plus 2 is the third term. And using that, we can do the second minus first. So x divided by x minus 1 is the first way to find the common ratio. And then the other way we have to do so is the third divided by the second. So that's x plus 2 divided by x. And since the common ratio does not change, we can set those equal to each other. And by cross multiplying, we get x squared equals x plus 2 times x minus 1. Then by multiplying out the x plus 2 times x minus 1, we get this. And then negative x plus 2x becomes just x. The x squares cancel. You're left with 0 equals x minus 2, and x equals 2, and that's your answer. Here we have we're doing the same thing as we were before, except that we're just finding the ninth term. So here we have the second divided by the first term is -3 divided by radical 3. Normally we wouldn't want to rationalize the denominator, but it would make it easier in this problem, so we will do that. So we'll multiply it by radical 3 over radical 3. The radicals cancel in the denominator, and then the 3's cancel, and you're left with negative radical 3. Now we plug that into the formula, and we get the first term is radical 3, and the common ratio is negative radical 3. And then we plug in 9, and now radical 3 is actually just 3 to the 1/2. And the negative in that situation can be eliminated since 8 is a even number, so the negative would be canceled out no matter what. So 3 to the 1/2 to the 8th is actually just 3 to the 4th, which can be simplified to 81 radical 3. So in this problem, we're going to be using the formula and then just plugging in values of a sub n, r, and n. So we have, this is the formula. So a sub n is 64 radical 2. We don't know the first term. And then we have a common ratio of radical 2. And since we're dealing with a sub 5, n equals 5, so we can plug that in for n. 5 minus 1 is 4. And as we did in the last problem, radical 2 is 2 to the 1/2. And 2 to the 1/2 to the 4th is just 2 squared. So that's 4. And then 64 divided by 4 is 16. And you've got your answer. Hope you enjoyed this video.